Hey everyone, how's it going? Today we are going to be solving another two-pointer problem, 2 sum 2, where the this is two integers sum 2, and this is essentially where the list of numbers that we're given is in non-decreasing order. So given an array of integers that is sorted in non-decreasing order, it's important to note, return the indices one index of two numbers, index 1, index 2, such that they add up to a given target, and that index 1 does not is less than index 2. So note that index 1 and index 2 cannot be equal, therefore you may not use the same element twice. There will always be exactly one valid solution, and we have to use O of 1 space. So, so constant space. So here is an example. We have 1, 2, 3, 4, and we needed to return 1 and 2 because they return the target of 3, 1, and 2. The sum of 1 and 2 is 3. Since we are assuming 1 index 1, 2, we return 2. We're going to be working with numbers from 2, or we're going to have a list of a length from 2 to 1,000. Numbers can range from negative to 1,000, negative 1,000 to 1,000. And our target is going to be fitting within that range as well. I'm trying to think of this. How could we do this in constant time? Let's go ahead and kind of jot our ideas down. So the things that we have to take into mind is nums is sorted. We cannot use the same index. We cannot use the same index. Here's exactly one valid solution. And the example given is 1, 2, 3, 4, where the target equals 3, and so we would return 1 and 2. Okay. One and 2. I mean, obviously we could think of the brute force solution, which would essentially just be loop through every number, and then under that, for every number, loop through every number, and then we could essentially return match when found. This is pretty straightforward. Time, space. So in terms of time, for every number that we're doing, we're going to be looking at every other number in the list, so that's n squared. In terms of space, it's just O of 1 because we're not storing anything. But this is still not as efficient as it could be. I think we need to pay attention to the fact that it is sorted. That kind of helps us narrow down what we're looking for, right? I think if it is sorted, we can do something like binary search, because we can essentially cut through our list of items half every single time. So like, let's say for instance, we were given 1, 2, 3, and 4 again. If we start with a left pointer and a right pointer here, we can see that 1 and 4, we could start eliminating. So we could see where this, so we could see that we have 1 and 4 equals to 5. That does not equal to 3, so we need to decrement right, and then we'll have 1 and 3 equal to 4. That does not equal to 3, and since 4 is greater than 3, we could decrement right again. I don't think this is technically binary search, but this is a method to help kind of reduce having to compare every number by using a two-pointer approach. So really this is just a two-pointer approach. Essentially we decrement right if our current sum is greater, and then we increment left. So essentially what we're doing here is left and right pointers, and then we have left and right pointers, and then we increment left if, so this is, yeah. So we increment left if left is, or if sum is greater than t, and then we decrement r if sum is lower than t. Yeah, this sounds pretty straightforward. Let's talk about the time, which would be O of n, because we're looking through the entire list, and space, again, is constant because we're not storing anything besides left and right. Alright, let's go ahead and code this out. I can't think of anything on the top of my head, but leave a comment down if I might have missed something. So LR equals 0, and the length of numbers minus 1, while left is less than right. Right, so while left is less than right, we have our current sum, which would equal numbers at L plus numbers at R. If our current sum is less than our target, so if our current sum is less than our target, if our current sum is less than our target, we need to increment left. So L plus equals 1, else R minus equals 1. Well, actually, we should check to see if it hits our target first. Return L comma R. L if current sum is less than target. Otherwise, we just return 0, 0. Yeah, so let's go ahead and take a look at this. So we set left to 0. Let's go ahead and apply this to our example. 1, 2, 3, 4. So here we start L here and R here. The current sum would equal 5. So 5 does not equal our target. Our target would be 3. 5 is greater than 3. So then, because 5 is greater than 3, right decrement, so L, R, and this would be 4 is greater than 3, so then we would decrement L, R, and then that would be 3 equals 3, so we would then return L and R. This looks about right. Let's go ahead and submit it. Oh, it's 1 indexed. That makes sense. Let's go ahead and do that. So we got to add 1 to our indexes here since it's 1 index and not 0 indexed. Alright, sweet. Looks like we went ahead and solved that using the 2-pointer approach. Awesome.